Welcome back, my lunar littering space lawyers. I'm your quantum superposed cosmic bailiff, simultaneously filing and ignoring extraterrestrial property violations across infinite realities. You're tuned into the Multiverse Employee Handbook, the only podcast that treats your cosmic real estate management like a filing cabinet that exists in all possible states of organization until someone desperately needs Form 27B6. Speaking of bureaucratic black holes, I'm delighted to report that Quantum Improbability Solutions has discovered they're legally responsible for all human space debris due to what our legal department charitably calls a minor clerical oversight in the 1967 Outer Space Treaty. Apparently, when the original treaty stated that no nation could claim celestial bodies, someone in our interdimensional contracts division interpreted this as dibs on cleanup duty.
Yeah.
The executives have now implemented mandatory cosmic liability insurance for all employees, covering space objects we've never launched, missions we've never planned, and debris from timelines that may not technically exist. But today, we're diving into something that makes our corporate liability issues look positively quaint: the moon's mounting storage crisis. You see, for the past 65 years, humanity has been treating our nearest celestial neighbor like that one friend's garage where you temporarily store your old furniture, except instead of a dusty exercise bike and Christmas decorations, we've left 200 tons of spacecraft, scientific equipment, and at least 96 bags of astronaut waste. That's right. The moon has become humanity's first accidental extraterrestrial storage unit, and unlike your typical self-storage facility, there's no earthly way to clean out your unit when you stop paying rent. Because as it turns out, in the cosmic real estate market, every deposit is non-refundable, every lease is permanent, and the only eviction notices are delivered via asteroid impact. So buckle up for our trashy tour of lunar real estate, where we'll explore how 65 years of quick trips to the moon have created the universe's most expensive archaeological site, and why somewhere in the quantum foam of bureaucracy, there's probably a bill collector wondering when Earth plans to start paying storage fees. But first, gather round the quantum filing department, my archaeologically ambitious administrators, for a tale that would make even Neil Armstrong question his dietary choices. In the fluorescent-lit realm of quantum improbability solutions, specifically in the newly established Lunar Heritage Conservation Division, which existed in a superposition of critical government contract and elaborate office prank, Miranda was having what could charitably be called a prestigious career opportunity crisis. It had started, as these things often do, with the most exciting email a summer intern could possibly receive.
Email.
Subject: congratulations! Classified assignment approval! Miranda, you've been selected for our most prestigious catalog initiative, comprehensive analysis of 96 critical Apollo-era specimens currently preserved in optimal lunar storage conditions. This is the assignment every space historian dreams of. Report to Secure Research Bay 7 tomorrow. Hashtag Lunar Legacy. Hashtag Cosmic Curator. Hashtag Top Secret. The next morning, she arrived to find Dr. Wavelength, the department's most distinguished senior researcher, waiting with a hazmat suit and an expression of profound reverence. Miranda, Dr. Wavelength intoned with Nobel Prize gravity, what you're about to undertake represents one of the most significant archaeological endeavors in human history. These specimens have been preserved in pristine lunar conditions for over 50 years. Each specimen must be catalogued with extreme precision. Dr. Wavelength continued, handing Miranda a sophisticated database interface. Temperature, consistency, structural integrity, and any signs of, biological preservation. "Are we looking for signs of lunar life?" Miranda asked excitedly. "Something like that. This work is classified at the highest levels. You're handling materials that could revolutionize our understanding of long-term space survival." For 3 weeks, Miranda threw herself into the work with total dedication. The specimens were sealed in what appeared to be advanced preservation containers that looked suspiciously like ordinary plastic bags, but she assumed this was disguised NASA technology. "Specimen AB 11001," she would dictate professionally, "exhibits optimal preservation integrity. Consistency appears stable." Every morning, Dr. Wavelength would ask for updates with cancer research intensity. The square-haired boss would stop by weekly, his cubic geometry vibrating with excitement. "Miranda, how goes our most critical research initiative?" "Very well, sir. I'm finding fascinating variations across different mission specimens. Some show signs of potential microbial preservation that could revolutionize extremophile survival understanding." By week 3, Miranda had created the most comprehensive database of Apollo biological specimens in existence, complete with theoretical models for long-term lunar preservation. That's when Dr. Wavelength entered with an expression combining pride, embarrassment, and barely suppressed laughter. "Miranda, we need to have a conversation about your remarkable work. Has NASA requested to review my findings?" "Miranda, what you've been cataloging isn't exactly... These aren't lunar rock samples." "Then what are they?" "You've been conducting the most comprehensive analysis ever undertaken of Apollo astronaut waste products. Specifically, 96 bags of astronaut biological waste that crews jettisoned on the lunar surface." Miranda stared at her carefully labeled containers. "These are bags of poop?" 50-year-old lunar-preserved bags of astronaut poop, yes. "But the security clearance? The classified status?" That's when the square-haired boss materialized, his hair achieving geometric sheepishness. "Because, Miranda, we've been trying to get someone to take on this project for 3 years. 43 people have turned it down the moment they realized what they'd be analyzing. You tricked me into cataloging space poop. You've done work that no one else was willing to do," the boss said gently. "You've approached it with more scientific rigor than most people bring to analyzing moon rocks. Your work might actually help us understand whether life can survive the journey to Mars," Dr. Wavelength added. "These specimens are our closest thing to a long-term biological preservation experiment in space." Miranda was about to respond when her analysis computer began beeping frantically. Specimen AB 17038 was displaying impossible readings: metabolic activity, cellular division, genetic material that appeared to be evolving. "Dr. Wavelength, you need to see this." "Is that active biological processes?" Dr. Wavelength whispered. "Specimen AB 17038 shows signs that it's not just preserved microbes surviving in lunar conditions," Miranda announced with textbook rewriting calm. "It contains a completely new life form that evolved from the original biological material in the lunar environment." The boss's hair practically sparkled. "Miranda, you've just made the most significant biological discovery in human history while doing a job nobody else would accept. Will I get to name the new life form?" "You'll get to name it and present the discovery to NASA," Dr. Wavelength confirmed. "You're about to become the youngest person ever to discover a new form of life, one that evolved from human waste on another celestial body." "You know what?" Miranda said, watching the readings that would rewrite astrobiology textbooks. "This is definitely cooler than regular moon rocks." And that, my scientifically dedicated colleagues, is how Miranda discovered that sometimes the most important research involves things nobody wants to discuss at dinner parties, until they evolve into the first known extraterrestrial life forms and become the only thing anyone wants to talk about at any party, anywhere, ever. And that brings us to the fascinating science behind why the moon has become humanity's most permanent parking lot. Unlike Star Trek transporters that can conveniently beam objects up and down at will, lunar missions operate under the iron-fisted rule of orbital mechanics. And in this cosmic game, every trip is strictly one way, unless you bring your own rocket fuel home. The moon's gravitational field creates what scientists call a gravitational well, which is essentially cosmic quicksand for spacecraft. Once you're in, getting out requires escape velocity, roughly 2.4 kilometers per second. Here's the cosmic catch-22. Achieving that escape velocity requires fuel, and fuel has mass. And carrying that mass requires more fuel. Most missions solve this problem by simply not solving it. They accept that whatever goes to the moon stays on the moon, like a cosmic version of Las Vegas with considerably more vacuum. This permanent parking situation began on September 14, 1959, when the Soviet Union's Luna 2 became the first human-made object to achieve what we might charitably call aggressive lunar integration. Luna 2 established the precedent that all subsequent space agencies would follow. When in doubt, leave it there and call it scientific equipment. The physics of lunar littering is elegantly simple. No atmosphere means no decay, no weather means no erosion, and minimal seismic activity means your debris will sit exactly where you left it for approximately the next billion years. Everything from Soviet pennants to American flags, from scientific instruments to lunar rovers, from crashed orbiters to 96 bags of biological waste, it all becomes part of humanity's permanent lunar archaeological record. NASA now considers some of these materials among the most valuable specimens for understanding long-term space survival, though they're discovering that finding researchers willing to catalog certain types of 50-year-old specimens can be challenging. When we return from this brief quantum inventory assessment, we'll dive deeper into how this cosmic storage crisis became humanity's first accidental collaborative venture, and explore why the moon's property laws are simultaneously the most and least enforceable in the solar system. Welcome back, my cosmic property assessors. While you were away, our automated billing system has been calculating the square footage of all human-made craters on the lunar surface. Spoiler alert, the moon now technically qualifies as humanity's largest storage facility, with more accumulated junk per square mile than a suburban garage sale in quantum superposition. Meanwhile, executives at Quantum Improbability Solutions have been fermenting some new ideas about our lunar asset diversification strategy, which apparently involves selling naming rights to individual craters and offering premium burial services for defunct satellites. Though I should note that our legal department has just discovered that every piece of space debris comes with its own competing ownership claims, making lunar real estate law significantly more complicated than a time-traveling divorce proceeding. We've also discovered that our newly established Lunar Heritage Conservation Division is currently training summer interns to handle materials so classified that they don't actually know what they're analyzing, which is creating some interesting performance review conversations. Let's begin with the fundamental question that has plagued space lawyers since 1959. Who exactly owns all this lunar junk? And more importantly, who's responsible when your decades-old spacecraft starts cluttering up the cosmic neighborhood? The answer begins with the Outer Space Treaty of 1967, a document that reads like it was written by particularly optimistic philosophers who assumed humanity would approach space exploration with the same level-headed cooperation we demonstrate at international climate summits. Article 2 states with admirable simplicity that outer space, including the moon and other celestial bodies, is not subject to national appropriation by claim of sovereignty, by means of occupation, or by any other means. In other words, no one owns the moon, which sounds wonderfully egalitarian until you realize this means no one is responsible for the moon either. It's like declaring that the office break room belongs to everyone, which inevitably means it belongs to no one. And suddenly, you're wondering who's supposed to clean the mysterious substances growing in the communal refrigerator.
Yeah.
But here's where physics makes the whole ownership question delightfully absurd. Territorial claims require the ability to enforce boundaries, and boundaries in space are about as meaningful as dress codes in a black hole. On Earth, we mark property lines with fences, walls, and strongly worded signs. In space, your property line is defined by gravitational fields, orbital mechanics, and the fundamental impossibility of building a cosmic fence that doesn't immediately violate several laws of physics. Consider the physics of lunar real estate. Without an atmosphere, there's no weather to erode your property markers. Without significant geological activity, your boundaries won't shift due to earthquakes or volcanic activity. But without gravity comparable to Earth's, there's also no practical way to maintain any permanent surface installations that aren't either anchored deep into the regolith or massive enough to resist the occasional micrometeorite impact. This is where our lunar debris becomes fascinatingly problematic. When Luna 2 crashed into the moon on September 14, 1959, it created the first human-made modification of another celestial body. The Soviet Union didn't claim the moon, but they certainly left their mark, along with Soviet pennants and medallions that are still sitting in Mare Imbrium, like the ultimate "I was here" graffiti tag. Luna 10, launched in March 1966, became the first artificial satellite of the moon, orbiting for 56 days before its orbit decayed and it joined the growing collection of Soviet real estate on the lunar surface. This established the pattern that continues today. Lunar orbit is essentially a temporary parking lot where the parking meters run on gravitational physics rather than quarters. Think of the moon as the universe's first no-fault storage facility. Unlike earthly storage units, there's no monthly fee, no access hours, and absolutely no possibility of cleaning out your unit when you move. The physics of escape velocity ensures that once you've parked something on the moon, you'd need to launch an entirely new mission just to retrieve a single tool left behind by a previous expedition. The economic absurdity is staggering. It currently costs roughly $10,000 to $20,000 per kilogram to send material to the moon. By that calculation, the simple hammer left behind by Apollo 12 astronauts represents approximately $40,000 in launch costs, making it quite possibly the most expensive hammer in human history. But the real cosmic joke is this. The moon's weak gravitational field means that establishing any kind of permanent presence requires massive infrastructure investments. But the same physics that make it expensive to build there also make it prohibitively expensive to remove anything once you've built it. It's like buying a house where moving in costs millions of dollars, but moving out is literally impossible without rebuilding the entire moving industry from scratch. The Americans learned this lesson repeatedly throughout the Apollo program. Every lunar module descent stage, every piece of scientific equipment, every rover, and yes, every bag of biological waste became a permanent lunar resident not by choice, but by physics. NASA didn't plan to litter the moon with 6 landing sites worth of equipment. They simply couldn't afford the fuel costs to bring any of it home. This is why the moon represents the ultimate cosmic commons, a shared space that no one owns, everyone uses, and nobody can clean up. It's like the universe's most expensive community garden, except instead of sharing tomatoes and arguing over composting, we're sharing crater impact sites and arguing over who's responsible for 65 years of accumulated space debris. The physics of cosmic property law can be summed up quite simply. In space, possession isn't 9/10 of the law, it's 100% of the law. Because once you possess something on the moon, the universe's physics conspire to ensure you'll possess it forever, whether you want to or not. Here's where our lunar storage crisis becomes genuinely remarkable. Despite decades of terrestrial tensions, Cold War rivalries, and the kind of international competition that makes Olympic ceremonies look like casual neighborhood barbecues, humanity has accidentally created our first truly collaborative extraterrestrial archaeological site. The Soviet Union started this cosmic neighborhood in 1966, when Luna 10 became the moon's first artificial satellite, establishing what we might call the orbital suburbs, a collection of spacecraft that would eventually decay and crash, creating the foundational layer of our lunar commons. Luna 10 was followed by Luna 11, 12, and 14, each adding to what was becoming an inadvertent international monument to human space exploration. Meanwhile, NASA was creating its own orbital subdivision with the Lunar Orbiter series, 5 spacecraft launched between 1966 and 1967 that were all deliberately crashed at mission's end to prevent interference with Apollo operations. It's like the ultimate cosmic urban planning, carefully placing your space debris to avoid cluttering up the prime real estate where you plan to land humans. But the real international collaboration began with the Apollo program's permanent installations. Starting with Apollo 11 in July 1969, the Americans didn't just visit the moon. They established 6 distinct neighborhoods across the lunar surface. Each site contains a descent stage that serves as the foundation for what amounts to humanity's first extraterrestrial suburbs, complete with scientific equipment, commemorative plaques, and enough abandoned camping gear to outfit a cosmic Boy Scout jamboree. Apollo 15, 16, and 17 added the moon's first automobiles, 3 lunar roving vehicles still parked exactly where their astronaut drivers left them decades ago. These aren't just abandoned cars, they represent humanity's first attempt at extraterrestrial urban transportation infrastructure. The rovers are still sitting there, their tires maintaining perfect tread because there's no weather to wear them down, like the ultimate example of low-maintenance public transportation. The truly international character of our lunar commons became apparent in recent decades. China's Chang'e program has established a substantial presence on both the near and far sides of the moon. Chang'e 3's successful landing in 2013 placed the U-2 rover in Mare Imbrium, practically within shouting distance of old Soviet lunar landing sites. Chang'e 4's historic far-side landing in 2019 brought the still operational U-2 rover to the Von Karman crater, creating humanity's first permanent far-side research station. India joined the neighborhood with mixed results. Chandrayaan-2's Vikram lander crashed in 2019, creating an extensive debris field near the lunar South Pole, but Chandrayaan-3 triumphantly achieved India's first successful soft landing in 2023. Japan's Slim lander demonstrated precision landing capabilities in 2024, albeit while landing nose down like a cosmic faceplant that somehow still managed to operate successfully. Even Israel contributed to our shared lunar heritage when Bereshit crashed in 2019, accidentally introducing thousands of tardigrades to the lunar environment, making the Moon potentially the first celestial body to host Earth life, even if that life is currently in cryptobiotic suspension, wondering why space is so inconveniently vacuum-like. Here's the remarkable thing. This international lunar community exists despite the fact that many of these nations maintain tense relationships on Earth. Soviet and American hardware sits within kilometers of each other on the lunar surface. Chinese rovers operate in the same cosmic neighborhood as NASA equipment, and Indian landers share the same celestial postal code as Japanese precision landing demonstrators. The Moon has become what political scientists would call an accidental commons, a shared resource that emerged not through careful international negotiation, but through the simple physics of space exploration. Every space agency that has successfully reached the Moon has contributed to this growing archaeological site, creating what amounts to a 200-ton testament to human technological achievement. But here's where our lunar commons becomes philosophically profound. Unlike terrestrial archaeological sites, which preserve the past, the Moon preserves the present continuously. There's no decay, no erosion, no gradual weathering that slowly erases human artifacts. Neil Armstrong's first footprints are still as crisp as the day he made them in 1969. The tire tracks from the lunar rovers still mark the regolith with the same precision as when they were created. This means the Moon serves as humanity's first permanent extraterrestrial museum, a place where our technological evolution is preserved in real time, where Soviet engineering sits alongside American ingenuity, where Chinese precision shares space with Indian determination, where Japanese innovation neighbors Israeli ambition. The philosophical implications are staggering. In our attempt to explore space as competing nations, we've accidentally created the first truly international territory. The Moon doesn't care about your space agency's budget, your nation's political system, or your mission's original objectives. It simply preserves everything equally, creating a cosmic commons where human achievement is measured not by national flags, but by our collective ability to escape Earth's gravitational well and leave something meaningful behind. In the end, our lunar commons reveals a profound truth about human space exploration. Despite our terrestrial divisions, when we reach for the stars, we inevitably reach together. The Moon has become our shared testimony that humanity's greatest achievements happen not when we compete for cosmic territory, but when we accidentally create something larger than any single nation could accomplish alone. And somewhere in the quantum bureaucracy of cosmic property management, there's probably a collections agent wondering when Earth plans to start paying storage fees. While in a nearby classified laboratory, someone is discovering that our most embarrassing lunar legacy might be our most scientifically valuable. Well, my extraterrestrial property managers, we've reached the end of another quantum cosmic real estate adventure. Today we've learned that in the multiverse of lunar storage agreements, every human-made object exists in a superposition of legally binding and completely unenforceable until observed by an interdimensional collections attorney. We've discovered that the moon has become humanity's first truly international territory by accident. A 200-ton testament to what happens when you combine human ambition with the unforgiving physics of escape velocity. From Luna 2's pioneering parking violation in 1959 to Chang'e 4's ongoing far-side operations, we've created the universe's most expensive archaeological site without ever meaning to build a museum at all. Though I suspect somewhere in the quantum foam of reality, there's a universe where all space debris pays property taxes in cryptocurrency, maintains valid cosmic parking permits, and files quarterly reports with the Intergalactic Revenue Service. In that universe, a corporation like Quantum Improbability Solutions actually makes logical decisions, and summer interns are told exactly what they're analyzing before they spend 3 weeks cataloging it. And if you've enjoyed today's lunar littering adventure, why not share it with a fellow space debris enthusiast? Perhaps you know someone who's ever wondered who's responsible for cleaning up humanity's cosmic messes, or someone currently involved in extraterrestrial property disputes. Spread our signal like gravitational waves, carrying overdue notices across space-time. Our Lunar Heritage Conservation Division is quietly training the next generation of space archaeologists, though they're discovering that the most important scientific work sometimes involves materials that nobody wants to discuss at dinner parties. This is your quantum coherent correspondent, reminding you that in the multiverse of cosmic commons, we're all just temporary tenants in the vast storage facility of space-time, leaving behind artifacts and memories for future civilizations to discover and bill us for. And speaking of discoveries, I've just received word that classified research has revealed something remarkable about our lunar archaeological sites, but apparently that's a scientific breakthrough for another security clearance entirely.
The Multiverse Employee Handbook was created by Rob Corrigan. The host, David, is a professional voice actor who has digitized his voice through ElevenLabs voice cloning technology. All episode thumbnails are created with OpenAI, and music and sound effects come from Pixabay, which are generated by human artists. Everything else, the writing, jokes, research, sound editing, and coffee consumption, is 100% human-made by a human. No cats are harmed in the making of this podcast. Visit our website for more information about the Multiverse Employee Handbook.